Hello everyone, welcome back. Today we will be looking at ControlNet for Stable Diffusion. Uh, in this video I'll go over why we need ControlNet and how we can install ControlNet with our automatic 1111 setup, and what are the different types of options that are available in a ControlNet and some example images for them. First thing, why do we need ControlNet? Most of the images we generate through automatic 1111 using Stable Diffusion. We don't have much control over the pose or the background. So generally we generate like 20, 30 images and we'll try to pick the best one that we like. But what if we want to get a particular pose or a particular uh, background setting? Uh, then it's really difficult to get that. So ControlNet helps us to uh, transfer, to give control over our image. It transfers style. We can transfer the segmented images. We can transfer poses and all these things. In order to set up ControlNet, go to extensions, go to available, load from, and search for ControlNet and just click on install. Since I have already installed it, I have it here. And once you install it, make sure you do apply and restart UI. So then we'll have then that will add a option here for the ControlNet. So just open it. So in ControlNet we have two major things. One is a preprocessor, one is a model. Uh, Preprocessor is mainly used to prep our input image and get the features from that, and model is used mainly to transfer this whatever the preprocessor extracted, right? Transfer that into our uh, text to image. Let's look at how ControlNet works with an example. Let's start with OpenPose. In OpenPose, we have multiple options: OpenPose, face only, full, and hand. Let me take an example and go through that in detail. Let me just take an input image. Now let's start with OpenPose, right? And once we click on pre-process the image, it is going to detect the pose, uh, and it is going to uh, transfer this pose to the new image that we are going to generate. Let's look at face. Here it is going to detect face also along with the pose, and the next one is face only. It's not going to worry about the pose. We are just going to get the face. And the next one is let's look at hand, where it will try to detect the pose along with the hand. uh, if we see the open pose, right, we were just getting the pose but not the uh, fingers. But once we select hand, it is going to detect the hand and what signs the hand is making. And the last one is open pose full, which is going to detect hands, pose, face, everything. Okay, let's start with pose. Okay, and previously I just generated image of a baker, and uh, it has generated a random image without any control. But I want to generate a baker in this pose, and let's see how it is going to generate that image. So you can see this image is more closer to this pose. Let me generate one more image. Yep. Now let's select face only. We might not get a good image here because here the feature is too far. If we have a close-up of a face, then we will be able to get more features from the face. Next, let's do one where we can get both face and image. So, yep. And then let's get one where we'll get the hand. Um, Ideally, there should be a peace sign. Yep. And if we select open pose full, we'll get hand, pose, and the face. Okay. Let's try to generate all the preprocessor images and try to compare them side by side. I'm saying uh, plot the images in this order: open pose, face only, face, hand, full. Now let's come here and generate an image. Okay, let's look at this. So the first one, only pose. The second one, face only. The third one, pose and the face. So we got both pose and the smile on the face. Third one is pose, like we have the pose and the hand. And the last one, we have everything. So you can experiment more with OpenPose. Next, look at a reference. So a reference does not use a control model. Basically, the generated, like whenever we use reference, the output images generated are similar to the input images. So we have reference ADIN, which is adaptive instant normalization. We have reference only, where uh, the input images attention layers are directly referenced by the output image. ADAIN is typically for the style transfer, and both ADIN plus attention will have a blend of both the images. So let's just quickly generate an image with these three preprocessors and see. So we are not trying to transfer a model or a pose. We are just, it's overall uh, feel of the image, right? The similarity of the image. This image looks more like this. So reference typically doesn't use a control model. It's more of a style transfer. Okay, now let's look at Canny. Before I have a text prompt like this: girl standing in front of a door, anime style. So let me just generate an image. We got an image. It's more accurate to the text that we provided here, but I want more control over that image, right? I want an image like this. So now let's just enable it. Typically when I just click on Canny, it will automatically select the preprocessor and the model. So now when I generate the image, right, you can see this image is accurate to the text we sent, a girl standing in front of the door, but it is more unique to the uh, Canny image, right? So basically in the preprocessor, it's an edge detector. So Canny is mostly used to keep the composition of input image as it is. So here the composition, in the sense, we have a door, we have a girl, she's holding something, and in the background we have some buildings. So what we will be using Canny in a scenario where we want to keep the composition of the input image. Even if I create one more image, right? Yeah, we'll still get a image which is pretty close to the image that we provided as input. Next, let's look at depth. So we have multiple options here. We have Midas, Leres plus plus, and Joe. So these are all the preprocess. So Midas is a like a classic depth estimator, and Leras we will get some background, and Leras plus plus we will get even more details in the background, and Joey is somewhere in between Midas and Leras. We don't get much background, we get more details in the depth of the main subject itself. So let's see what kind of image we get with, like I need to enable it. Okay, okay, yeah. Let me generate some images. So the first one is just depth. So we have the subject, but the background is not that detailed. Little bit detail in the background, more details in the background, uh, details in the background, and on the subject too. Okay. Next, let's look at line art. In line art, basically, the image will be converted to a simple drawing. So we have anime, where we have anime style drawing, anime denoise, where it's same anime drawing but with less details. We have anime realistic, where it is more detailed, and coarse, where the lines are more lines have more weight, so it's more it carries more weight at the output image. Now let me try to plot uh, all these pre-process uh, in one image. So these images are almost similar, but based on uh, our preference, right? Like you can start experimenting, you know the difference between multiple preprocessors, right? So whichever image is more suited for your use case, you can make use of that preprocessor. Next one is MLSD, which stands for Mobile Line Segment Detection. Basically, this preprocessor is for detecting straight lines. It is very similar to line art, but more focused on straight lines. So if I generate an image based on this, we can see that this image is more close to uh, what we provided. Like there is a tall building in the middle, and beside that there are like small buildings. So that is what it is detecting, and that's what we'll be getting here. Next one is normal. In normal map, we have two preprocessor. One is BAE and the other one is Midas. Midas is pretty similar. So here it will generate a normal map where it separates the subject from the background. So this is useful whenever you want to uh, take you isolate your subject from the background. And BAE, it will generate normals for both subject and also the background. So let me plot both of them. So here we got an image based on our input image, but there is no background here. So this is really helpful whenever you want to isolate your subject from the background. You can use normal map. And where you will be getting the background also. Next one is Scribble. In Scribble, we have HED where uh, it will generate the scribble lines that are very rough and thick. I mean, the lines have weight here. When we look at PDNet, uh, it is similar to HED but with less details. And XDoG can vary the amount of detail using the threshold. Now let me plot multiple scribbles. More detailed, even more detailed since we reduced the threshold for XDoG. Next one is segmentation. In segmentation, we have three different options. First one is OFADE20K, that is one former which is trained on ADE20K dataset. So that, and then we have one former which trained on COCO dataset of images, and we have uniformer that is trained on AD20K dataset. So all three of them has different specialities. Again, based on your use case, you can experiment with which preprocessor is able to identify the segments in your image properly. Again, three different preprocess and play around, and whichever one that best suits your use case, use that. Next, let's look at how we can embed text onto the image that we are generating. So generate the text image either by PowerPoint or Canva or whatever, and just paste that image as the input to your ControlNet. Then use line art standard as a preprocessor that will give us an output like this. Then we can select line art anime and then provide whatever the background that we want, and then just generate an image. So yeah, here it will use the pre-processed image as input and we'll get it here. Let's say something like, again, it's very accurate and we have text on the image. That's it. See you all in the next video.